Hello and welcome. Today we will be reading the book Computer Coding for Kids. It's a unique step-by-step visual guide from binary code to building games by Carol Vorderman. First of all, what is coding? What is a computer program? A computer program is a set of instructions that a computer follows to complete a task. Coding or programming means writing the step-by-step instructions that tell the computer what to do. Computer programs are everywhere. We are surrounded by computer programs. Many of the devices and gadgets we use each day are controlled by them. These machines all follow step-by-step instructions written by a computer programmer. Computer software. Everything a computer does, from browsing the internet to writing documents or playing music, works because of code written by a computer programmer. Mobile phones. Programs allow you to make a phone call or send text messages. When you search for a contact, a program finds the correct phone number. Games. Consoles are just another type of computer, and all the games that run on them are programs. All the graphics, sounds, and controls are written in computer code. Washing machines are programmed to follow different cycles. Computer code controls how hot the water is and how long the wash takes. Cars. In some cars, computer programs monitor the speed, temperature, and amount of fuel in the tank. Computer programs can even help to control the brakes to keep people safe. So how do they work? Computers might seem very smart, but they are actually just boxes that follow instructions very quickly and accurately. As intelligent humans, we can get them to carry out different tasks by writing programs or lists of instructions. Computers can't think. The computer won't do anything by itself. It's up to the computer programmer to give it instructions. Without instructions, the computer is clueless. So you write a program. You can tell a computer what to do by writing a set of very detailed instructions called a program. Each instruction has to be small enough that the computer can understand. If the instructions are incorrect, the computer won't behave the way you want it to. This is a computer program counting down to launch. Programming languages. Computers can only follow instructions in a language they understand. It's up to the programmer to choose which language is best for the task. All programs are finally converted into binary code, a basic computer language that uses only ones and zeros. Lingo, hardware and software. Hardware means the physical parts of the computer that you can see or touch. All the wires, the circuits, the keyboard, the display screen, and so on. Software means the programs that run on the computer and control how it works. Software and hardware work together to make computers do useful things. Let's think like a computer. A programmer must learn to think like a computer. All tasks must be broken down into small chunks so they are easy to follow and impossible to get wrong. Thinking like a robot. Imagine a cafe where the waiter is a robot. The robot has a simple computer brain. It needs to be told how to get from the cafe kitchen to serve food to diners seated at tables. First, the process has to be broken down into simple tasks the computer can understand. We have lingo, algorithm. An algorithm is a set of simple instructions for performing a task. A program is an algorithm that has been translated into a language that computers can understand. Let's look at Waiter Robot Program 1. Pick up food, move from kitchen to diner's table, put food down. Using this program, the robot grabs the food from the plate, crashes straight through the kitchen wall into the dining area, and puts the food on the floor. This algorithm wasn't detailed enough. It was a disaster. The instructions weren't clear. We forgot to tell the robot to use the door. It might seem obvious to humans, but computers can't think for themselves. Waiter robot program 2. Pick up a plate with food on it. Move from kitchen to diner table by. Move to door between kitchen and dining area. Move from door to the table. Put plate down on the table in front of the diner. This time, we've told the robot waiter to use the kitchen door. It makes it through the door, but then hits the cafe cap, trips, and smashes the plate on the floor. Still not perfect. The robot doesn't know how to deal with obstacles like the cat. The program needs to give the robot even more detailed instructions so it can move around safely. Waiter Robot Program 3. Pick up a plate with food on it, holding it level at all times. Move from the kitchen to diner's table by. Move to door between kitchen and dining area. Checking for obstacles and steering around them. Move from door to the table. Checking for obstacles and steering around them. Put plate down on the table in front of the diner. Success at last? Finally, the robot can deliver the food safely, but we forgot to give it instructions to go back to the kitchen and get the next plate. In this version of the program, the robot successfully delivers the food to the diner, avoiding any obstacles. But after putting the plate down, the robot remains standing at the table while food piles up in the kitchen. Let's look at a real world example. The waiter robot might be imaginary, but algorithms like this are in action all around us. For example, a computer-controlled lift faces the same sort of problems. Should it go up or down? Which floor should it go to next? Let's read the code. Wait until doors are closed. Wait for button to be pressed. If button pressed is higher than current floor, move lift upwards. If button pressed is lower than current floor, move lift downwards. Wait until current floor equals button pressed. Open doors. The lift program. For the lift to work correctly and safely, every step has to be precise, clear, and cover every possibility. The programmers have to make sure they create a suitable algorithm. Becoming a coder. Coders are the people who write the programs behind everything we see and do on a computer. You can create your own programs by learning a programming language. Programming languages. There are a huge range of programming languages to choose from. Each one can be used for different tasks. Here are some of the most popular languages and what they are often used for. C, a powerful language for building computer operating systems. Ada, used to control spacecraft, satellite, and airplanes. Java, works on computers, mobile phones, and tablets. MATLAB, ideal for programs that need to carry out lots of calculation. Ruby automatically turns lots of information into web pages. JavaScript, a language used to build interactive websites. Scratch, a visual language that's ideal for learning programming. This is the first language covered in this book. Python, a text-based language that can be used to build all kinds of things. It's the second language covered in this book. What is Scratch? Scratch is a great way to start coding. Programs are created by connecting together blocks of code instead of typing it out. Scratch is quick and easy to use and also teaches you the key ideas you need to use other programming languages. The program appears on this side of the screen. Code is made by connecting colored blocks together. What is Python? People around the world use Python to build games, tools, and websites. It's a great language to master as it can help you build all kinds of different programs. Python looks like a mixture of recognizable words and characters, so it can be easily read and understood by humans. This is an example of a program written in Python. Ghost game. Getting started. It's time to start programming. All you need is a computer with an internet connection. This book starts with Scratch, the perfect language to help you on your way to becoming a coding expert. Get ready to jump into the exciting world of computer coding. Expert tips. Enjoy experimenting. As a programmer, you should experiment with the code and programs you make. One of the best ways to learn programming is to play about and see what happens when you change different parts of the code. By tinkering and fiddling, you'll discover new ways of doing things. You'll learn much more about computer programming and have even more fun.